Hello everyone. In this video we're going to be talking about subnetting, easy subnetting, and we start with 5 questions of subnetting. And when you look at a network map, you might come across something kind of funny looking as far as like a slash. It could be slash 24, 25, 26. For example, you'll see a 192.168.1.0/26. And you might ask, like, what does that /26 mean? And so it actually kind of represents the number of ones in the octet in the subnet mask. And so a subnet mask can break a network into multiple networks. So for example, if you did have a network of 192.168.1, you could have 255 hosts. Actually, you'd minus 2 would be 253 hosts, or 253 hosts, because 2 of them, the first IP address would have to go towards the subnet, and the last one is always going to be the broadcast. So you can't really use 192.168.1.255. So we asked these 5 questions. How many subnets does the subnet mask have? How many hosts per subnet? What are the subnets? What is the broadcast area for each subnet? And what are the valid hosts for each subnet? And so again, the /26 to kind of represent the number of ones. And again, we went through converting decimal into binary. And so this, you can just lay out the IP address. Actually, the subnet mask of the IP address. And so 26 is going to represent the number 1. So if you do 26 ones, this is going to be 8, 16, 24, 25, 26. This is written out the 26 network. And so what that does is it leaves you with 6 zeros. And so to kind of make it easier, you can put X's in there to make it smaller. Kind of makes it a little bit easier. Then you kind of run through our calculations again of 128, 64, 32, 16, 8, 4, 2, and 1. And then if you write out the 2 that are ones, it would be 128 and 64, which equals 192. So the actual IP address, or the subnet mask, would be 255.255.255.192. And so when you're typing in your IP address and you need a subnet mask, instead of just using the default 255.255.255.0, you would actually put 192. And this breaks, again, it's going to break that network up into sections. Well, how many sections? How many subnet it's going to break up? And how many hosts do we have left? And so it's really important to note how many subnets. It's 2 to the power of the number of ones. And so right here you see this would represent 2 times 2, which is 4. So you would have 4 subnets. How many hosts? It's 2 to the power of the number of zeros. And since we have 6 zeros, we'd have to use 2 to the power of 6. And so, for example, I've kind of written this out. You have 2 times 2 equals 4, so you have 4 subnets. You have 2 times 2 times 2 times 2 times 2 times 2 equals 64 hosts. But you have to minus 2 because, again, one's going to actually represent the actual name of the network subnet. And so you can't use that IP address, and nor can you use the broadcast IP address. The broadcast IP address is always going to be the last IP address in that subnet. And to get the number, what are the subnets? You can do 256 minus the 192, where we got the 192. That equals 64. So this kind of shows you what the starting subnets are going to be. So it's going to start, one subnet is going to be 0. The next one's going to be 64. The third one's going to be 128. And the last one's going to be 192. That's 4 subnets. Now we're going to have to take out the broadcast, so they're always going to, broadcast will always end in 255. And so the first one's going to be 0.363. The next one's going to be 0.127. The third broadcast is going to be 191. And the last one again is going to be 255. And so now once you take out those networks, the IP addresses, now you can get what we can actually use for hosts. So the first subnet is going to be 1 through .162. The second one's going to be .65-.190. And the third one, actually I think there's one missing. And then you can't use 127 or 128, so 129. So again, the host that you can use is 1 through 62, 65 through 126, 129 through 190, 193, and 254. So if you're looking over an IP address and it has the /26, if you're looking at 192.168.1 network, in this, if it's subnetted, if you have a host that's a .61 and a host that's a .66, they're not on the same network because you divided the network. And so a layer 3 has to be able to connect those, because again, switches create networks and routers connect networks. And so in this scenario, you're creating 4 separate networks all on that one. And so instead of using the 192.168.1 and then the .2, the .3, the .4, you would be using 4 separate networks. You can break it down. You can use the single network of .1, .0 into 4 separate networks. And don't forget that we want to use VLANs and multiple networks versus having one large broadcast domain. So this is kind of a picture that shows this network is going to have be on the .0. This one's going to be the .64. This one's going to be the .128. This is going to be the .192. You can have one switch, which if you use VLAN, you can have one switch have all 4 networks on it. But again, you want to break up the broadcast domain, because a broadcast is when one PC, say it wants to get an IP address or a ping. If it wants to get an IP address from the DHCP server, it's going to have to broadcast because it doesn't know where to get the IP address from. If you want to ping, if the ARP, where it translates the IP address to the MAC address, if that's not set up in cache, again, a broadcast is going to have to hit every host in this network. So every computer is going to have to read that frame to see if it's for them, even if it's not. And so it really slows down the network. That's the big point. Alright, well that concludes our easy subnetting. I hope you found this easy, and if you need to watch it again, it's okay. Well, the first time I tried doing this, it's just repetition, doing it over and over.